So let's look at number 10. So they're assuming that you guys are going to remember how exponents work. So really quick, I'm going to give you a really quick rundown, okay? Okay, so if I was to write something like this, whatever number is on the outside always goes on the bottom. Whatever number is on the inside always goes to the top. So this is the bottom. Okay, this is the top. Now the reason, so what we need to do is we need to match these up, okay? It doesn't tell us if it's only going to be used once, twice, or if everything's going to be used. So let's just kind of go through here and see. So this could be written as, yes, or the square root of 25, which we all know is plus or minus 5, right? All right, so which one would match with that? Draw a line from each rational to its equivalent.
No.
So the directions probably should have been a little bit more clear because, so which one, right now the only one I see is this one. Okay, so I think that there's only one right answer. We'll see, we'll keep going. Okay, all right, so let's look at this one right here. Now, this is something that we haven't got to spend a lot of time with. Remember when I tell you about the calculators, that exponent is only hooked to the what? X. If it was the whole 4x, 4 and x would be in parentheses. So 4 is automatically on the outside. Okay, x is on the inside. Which one of these numbers goes on the outside here? 3. Which one goes on the inside? 2. So I'm looking for 4, the cube root of x squared. Okay, second to the last one. Good. Okay. Now, this one, it's just hooked to the x. That's all we have. Okay, so what number goes on the outside? 3. 1 is in there, but we really don't even have to write the 1 when it's a 1, right? So I need the cube root of x. Which one does that? Top one. Good. Okay. So we haven't gotten a lot of time to spend on these, but that's how those work, okay?
What work?
The exponents.
Oh my goodness.
All right, let's look at number 12. What is the inverse? Okay, we have not gotten to the inverses yet. Okay, remember for logs, but remember how if I had a regular equation, what did I tell you the inverses look like when we graph them? They have a something effect. They have a butterfly effect. Okay, so one thing you could have done is graph this and graphed the other one and seen if it gave you a mirrored effect. Okay, on the other ones, we would switch our x and y and solve for y. Okay, all right, now listen. Right now I have y equals 1/2 the log of 5 to the x. So I'm going to show you how I would do this. I am going to move my exponent up here. So I have y equals log 5. Anything to the 1/2 is the square root, but we'll just leave it as x to the 1/2. Okay? Now, the very first step is we switch x and y, right? So this becomes x equals this. Log of 5, y to the 1/2. All right. Is it okay? Am I going to mess anybody up? We've talked about switching these around. Can I move my x over here so that I can loop-de-loop it? Yeah. So what I want to do is I want to loop-de-loop this thing so that I can solve it for y. So let's loop it.
We lied, yeah.
That was gonna happen, didn't you? Phone call.
Okay. All right, here we go. 5 to the x equals y to the 1/2. Okay. This is like the saying the square root of y. How do I undo a square root? Square it, right? So I square it. Okay. Now I have power to power. What is 2 times x? 5 to the 2x equals y. So which one of those is 5 to the 2x? None of them.
Wouldn't it be?
So now what?
Okay, what is 5 squared? What is 5 squared? 25
So it's just
to the x. So do you see what I did? I just simplified. So I know that 5 squared is 25, but I don't know what the x is, so it still stays as my exponent. Okay? So it would be that one.
Oh, shit.
Okay? All right. Skip 13 for now. We'll come back to that one later. Okay?